Firewall operations on bridges. AshBlink NFV platform provides multiple virtual bridges with predefined rules between those virtual bridges. For example, network traffic from bridges BR1, BR2, and BR3 to WAN via BR0 will go through NAT, network address translation, by replacing the source IP address in the IP header with the IP address of BR0. Network traffic can go from BR3 to BR1 and vice versa. It's not allowed to go from BR1 to any other subnets, but traffic from the other subnets to BR1 is allowed. We will explore more details later in this document. The network traffic initiated from the hosts under BR0 is not allowed to go into the other bridges. The benefit of this configuration is, it is straightforward to place virtual hosts into the different zones according to the permission levels. And the firewall can control the access level in a global way with careful planning in advance. For each virtual host, if it is necessary to be deployed across different zones, it can have multiple virtual network interfaces placed into different bridges. Illustration 9. Virtual bridges inside base platform. The following diagram shows the network traffic from BR1 or BR2 via BR0 will be processed by NAT, network address translation, with the IP address of BR0 as source IP address, no matter it is from a virtual host or physical network interfaces under the bridge BR1 or BR2. Illustration 10. NAT while going across the boundary of BR0. Illustration 11. No NAT operation inside bridge BR1 and the virtual host placed under BR1 can be accessed via ETH1 without restriction from base platform. It depends on the virtual host itself to implement its own access control or not. If the virtual host does not have the control scheme, the firewall of the base platform can enforce some extra rules to have more finer control. It is forbidden to access the hosts in BR1 or BR3 from the hosts in BR0 unless port forwarding is used. Illustration 12. No NAT operation while going across the bridge boundaries BR1 and BR3. The hosts under BR1 and BR3 can exchange network traffic via the routing process provided by the base platform. Although those virtual hosts under the bridges are enclosed within the same physical entity, logically they are independent from the base platform. They have their own network identities, they are exactly the same as the other hosts outside the enclosed physical entity. From network point of view, they only can be accessed by their own IP addresses other than console. Thus, logically, they should be viewed as the hosts outside the physical host, just like the other hosts. Illustration 13. Virtual host connecting to the bridge BR0. We use a virtual host under BR0 as an example. A virtual host is created under BR0. The bridge BR0 is with an IP address and that is the identity of the base platform. The virtual host is also with its own IP address that is on the same subnet where BR0 resides. Although the outbound traffic of this virtual host to the internet should go through BR0, the traffic will not be touched by the operation of NAT. It goes out via bridging with its own IP address as source address. Thus, this virtual host is not protected by the firewall of the base platform. The other hosts under BR1 or BR2 just view the host in BR0 as a host outside the firewall. Similarly, a virtual host can have multiple legs into multiple virtual bridges. The following diagram is a virtual host with virtual network interfaces to the bridges BR3 and BR4. Thus, for network traffic originated from this virtual host to the two subnets where BR3 and BR4 reside, the virtual host is with direct link to the two subnets. They do not have to go through routing process of the base platform. There exists some network protocols that cannot go beyond a subnet. With this configuration, this virtual host can apply those network protocols to the two subnets respectively. Illustration 14. Virtual host connecting to multiple bridges. Firewall virtualization or SBC virtualization. If a virtual host is with two virtual network interfaces, one is under BR0 and the other is under BR1, then this virtual host can be implemented as virtual firewall or virtual SBC. Illustration 15. Virtual host connecting to bridges BR0 and BR1. This virtual host is with one interface in WAN and another in LAN so that it has the potential to become virtual firewall or virtual SBC. Since the base platform itself is a firewall as well, how to choose the firewall to use from the subnet that BR1 connects to. If the machines in that subnet use the IP address of that virtual firewall as default gateway, the traffic will route through virtual firewall to the internet. To force people to use virtual firewall, it only needs to turn off the DHCP server and provision the rule to forbid the traffic from BR1 to BR0 on the base platform. Therefore, people have no choice but use the virtual firewall to go to internet from that subnet. Similarly, virtual SBC can be deployed in the same way. Illustration 16. Virtual host connection for firewall virtualization. To avoid the confusion of the relation between base platform and virtual host, we might as well consider those virtual bridges as multiple Ethernet switches. The base platform has multiple legs plugged into those Ethernet switches with IP address defined on each leg, IP address defined on its bridge interface, whereas the virtual hosts also have legs into Ethernet switches. Each Ethernet switch is with hosts in the same IP subnet. The benefit of virtualization is that adding a network interface into a bridge can be done via software reconfiguration without actually putting a network interface card and wiring cables. And the base platform provides network method to access the consoles of the virtual host so that the console of a virtual host can be accessed remotely. The guest OS does not need to install any other software packages for this function. The base platform is also with OSPF and RIPv2 so that it can interface with the other routers to exchange routing tables automatically. Illustration 17, Base platform and other routers. Furthermore, the base platform also provides firewall functionalities. It is known as border control that will be introduced later in this document. It is possible that you might implement your own firewall in the virtual host by connecting the virtual bridges indicated earlier in this section. In the following chapter, we will introduce how to create a virtual host on the base platform.